Let's go over the practice test 2 in preparation for your exam number 2. Let's take a look at example number 1 or question number 1. Use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. And use the graph to determine the function's domain and range. In this problem, you're given the function here, f of x equal to x squared plus 3x minus 4. Now, to determine the axis of symmetry, you first get the x coordinate of the vertex of the parabola. The x coordinate is given by the formula x equals negative b over 2a. So x equals negative b over 2a. Now, b is the coefficient of x. So therefore, in this case, b is equal to negative 3. And then a is the coefficient of x squared. The coefficient of x squared is 1. So you have negative b, so that's negative 3 over 2 times the value of a, which in this case is 1. And then you simplify. So you have negative 3 divided by 2 times 1, and 2 times 1 is just 2. So you have the x coordinate of the vertex of the parabola is negative 3 over 2. And for the axis of symmetry, it is just a line. So it says here you type an equation. It is just actually the line x equals the x coordinate of the vertex of the parabola, negative 3. That's right, negative 3 over 2. Now, how do you identify the domain? The domain is always the set of all real numbers. Now, pay attention. It says here you type the answer in interval notation. So then you would have to type the answer as negative infinity to infinity, comma, and that's always open. What about the range? Now, to identify the range, you're going to determine the orientation of your parabola. Since a here is greater than 0, then you have a parabola that is opening upward. So a parabola would look like that. So therefore, the range will be from the y value up to the positive infinity. So in other words, you get first the y value. So that means you evaluate the function at the x coordinate of the vertex of the parabola. So you get the y value, y coordinate of the vertex of the parabola. You do that by evaluating this function here. So you have evaluate the function at x equals negative 3 over 2. So you have negative 3 over 2. Okay, let me see. Negative 3 over 2, and then you square it, plus, now we replace all x by negative 3 over 2. 3 times negative 3 over 2, and then minus 4. And this you can input to your calculator. Now let's open the Desmos calculator. This is a calculator that you'll be using on your test. So you have negative, and then you have the so let's have the parentheses first. And then you have negative 3 divided by, that's how you make a fraction, negative 3 over 2. That is our x coordinate. And close it in a parenthesis, square it because of that. And then plus 3 times, again, negative 3 divided by 2. Oops. negative 3 divided by 2, parentheses. So that is for the 3x. Again, you replace the x by negative 3 over 2. And then minus 4. That is the y-coordinate of your the vertex of the parabola. Now let's type in the answer here. So to type in the range, this would be the starting point. So now if you are, if you want to write it in fraction form, then you can, let's move this a little bit. Okay, so you can click on that button to actually get the fraction form. So you can say from negative 25 over 4, so to write the range, you would say that is included. So that would be the close bracket. So you do closed because this means it is included. And then you write the fraction. You have negative 25. That's negative 25 over 4. And then comma. You put a comma up to positive infinity. So up to infinity. And then that would always be open. Oops. That would always be open. Okay, so that's how you would type in your the range, because this is, as I've said, this is a parabola that is opening upward. So it's from the y-coordinate of the vertex up to positive infinity. So just to show you how to input the domain as well, you will have that, and then you just put negative because it's from negative. That's a negative. Negative infinity to positive infinity. For the axis of symmetry, it would always be x. So you write x is equal to the x-coordinate of the vertex of the parabola. So you have the fraction there, and or you can put the negative sign in the middle if you want to. So you have negative of 3 divided by 2. 3 over 2, and that would be the answer. Now let's consider another question. Consider this function here. Determine without graphing whether the function has a maximum value or a minimum value. Find the minimum or maximum value and determine where it occurs. And then find the function's domain and range. Now, to determine without graphing whether the function has a minimum or maximum value, all you need to do is to look at the coefficient of x squared. So look at the coefficient of x squared. In this case, you see that a is, so the coefficient of x squared is equal to 2. And 2 is greater than 0. So you have 2, which is greater than 0. And that implies that you have a parabola that is opening upward. So the graph would look like this. So if you have a parabola that opens upward, then the vertex is a minimum. That's the lowest point of the graph. So in other words, this function will have a minimum. So you would say minimum value. So it will have a minimum value. Now, and the minimum value is, so when you say minimum value, that's the value, that is actually the y-coordinate. So the minimum value means the y-coordinate of the vertex of the parabola. So to get the y-coordinate of the vertex of the parabola, you are going to get first the x-coordinate. Okay, so you have, so you compute for the x-coordinate, which is, which you can compute using the formula negative b over 2a. So you plug in the information, you look at the given parabola here. Okay, so b is the coefficient of x, so you have the negative of the negative of negative 20, that's your negative b, over 2 times the coefficient of x squared. So a is the coefficient of x squared, so 2 times a. So you have negative of negative 20, that's positive 20, over 4, that gives you 5. So it occurs at x equals 5, that's the x coordinate, and the value will be the y coordinate. So to get the y coordinate, you're just going to evaluate your function at the x coordinate. So in this case, at x equals 5. So you plug in 5 to the given function. So you have 2, and then you replace the x by 5. So 5 squared minus 2 times 20 times 5 minus 6. And then go ahead and simplify this. You have 2 times 25 minus 2 times 5 is 100 minus 6. 2 times 25 is 50 minus 100 is negative 50 minus 6 is equal to negative 56. So in other words, the minimum value in this case is negative 56. Y equals negative 56. Or you just say the value is negative 56. Now, what's the domain? So if you have a parabola or a quadratic function, the domain is always the set of all real numbers. And how do you write that? It's just negative infinity to positive infinity. What about the range? Go back again to the range. Again, this is a parabola that is opening upward. So the range will start from the minimum value, the lowest point, which is the y coordinate, and that's negative 56. So starting at negative 56, and that's included. So you use that, close parenthesis, up to positive infinity. Next, let's proceed to this question. Find the zeros for the given polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. This is the given function. All right, so to solve this, we will have to first factor this given polynomial function. So notice that x is a common factor to each term of the polynomial function. So you could write this as x. So factor out x first. You have x squared. So you divide each term by x, by the common factor. So this first term can be factored as x times x squared. So you have x squared minus, now for the second term becomes minus 20x if you factor out x. And then the 100x, if you factored x, will be 100. So plus 100. The next is to factor this given quadratic factor. So you factor x squared minus 20x plus 100. That could be factored as x minus 10 squared. That's a perfect square trinomial. So now we have our polynomial function in factored form. So let's determine the zeros. So the zeros are the zeros of each of the factor here. So you equate each factor to 0 and you solve for x. So for x, you equate that to 0. You have x equals 0. So one of the zeros are 0. What else? And then the 0 for this factor here. That means you would equate x minus 10, just the base. Equate that to 0, you solve for x, so x equals 10. So the other one is 10. So these are the zeros. Now let's determine the multiplicity. So let's determine the multiplicity. Now to determine the multiplicity, you just have to look at each factor and pay attention to the power. So here you don't see an exponent. That means the multiplicity is 1. And here you see that the exponent for x minus 10 is 2. So that means the multiplicity of x equals 10, the multiplicity of that root, 10, is 2. Okay, so, and also you have to be very careful when answering this type of question. So it says here there are 2 zeros, so that you know that A is the answer. The multiplicity of the smallest zero, what is the smallest zero? Between 0 and 10. Which one is the smallest? That is 0, right? So the multiplicity of the smallest zero is 1, because the power of x is 1, and the multiplicity of the largest zero is 2. Okay, so is not asking for the smallest zero and the largest zero, but rather it is asking for the multiplicity. So you give the multiplicity the power of the exponent. Okay, next, determine the behavior of the function at each zero and select the choice below. Right, so now we know that if the multiplicity is odd, that means that it crosses the x-axis. So that means the graph crosses. Our answer here is C, because we have the multiplicity. We have a multiplicity that is odd and a multiplicity that is even. So for the smallest zero, for x equals 0, the graph crosses at that point. So the graph crosses at x equals 0 because the multiplicity there is 1. Now the graph touches at x equals 10 because the multiplicity there is even. So it touches the x-axis and turns around at x equals 10. Again, let me emphasize, if the multiplicity of the zero is odd, the graph crosses the x-axis at that 0. If the multiplicity is even, then the graph touches the x-axis at that 0. Now let's take a look at the question here. Use the given function to complete parts A through E below. You are given the function f of x equal to x to the 4th minus 1x squared. Letter A. Use the leading coefficient test to determine the graph's end behavior. Now, to answer this question, we will have to look at the leading term of the polynomial and determine the degree of the polynomial. So the leading term is the term with the highest exponent. In this case, it is x to the 4th. So the leading term being x to the 4th, then we pay attention to the power, the degree, and it is equal to 4, which is even. Now, if you have an even degree, that means that the end behavior will either be all going up or everything's going down. Now, how do you know which one? You look at the coefficient of the leading term. If it is positive, like in this case, where it is equal to 1, then that means that both endpoints, the left and right, are rising. So that means the answer here is the graph of f rises left and rises right. So that means this behavior here. So that's the answer. Next, let's find the x-intercept. How do you find the x-intercept? This is the intersection at the x-axis. So this is the case when f of x is equal to 0. So in other words, you just equate the given expression here to 0. So you have x to the 4th minus x squared equal to 0 and solve for x. Now, to solve for x, you're going to factor. So you have x squared, you factor the expression here. Therefore, you have x squared times x squared minus 1 equal to 0. Then you solve. So you have here, that means x is equal to 0, x squared is equal to 0. And so therefore x is 0. And the other factor, which is x squared minus 1, is also equal to 0. Then you solve for x. So you have x squared is equal to 1. So therefore x is equal to plus or minus 1. So these are all the x-intercepts, the values of x when y is 0. So we have 0, 1, and negative 1. So you can arrange this in increasing order if you want to, or in any other order. Negative 1, 0, and 1. These are the x-intercepts. Now, let's answer the next question. At which zeros does the graph of the function cross the x-axis? So to determine whether the graph crosses the x-axis at that intercept, or it will just touch the x-axis, that is determined by the multiplicity of that root. So that is determined by the multiplicity of that root. Multiplicity means the number of times that it occurs. And you can determine that if you write your polynomial in factored form. So let's write our polynomial in factored form. So this polynomial here, let's write that in factored form. We already have it in this format where we have x squared and then we have x squared minus 1. Now, that is not completely factored. You could write that as well as x squared times x minus 1. So I'm applying here the difference of two squares formula. And then you have x plus 1. Again, if you don't remember that, you have x squared minus, if you have a squared minus b squared, using the difference of two squares formula, that is just that you could factor this as a minus b times a plus b. So that means that x squared minus 1 here could be factored as x minus 1 times x plus 1. Now that we have this in factored form, okay, so we have identified our zeros to be 0, 1, and negative 1 here. Then all you need to do is look at the multiplicity. So the zeros for which the graph crossed the x-axis are the zeros with odd multiplicity. And what are those? Those are the negative 1 and the positive 1. So we have 1 and negative 1 here. Those are the zeros. So at x equals 1 and negative 1, those are the zeros for which the graph crosses the x-axis. And the zeros for which the graph touch the x-axis and turn around is the zero with even multiplicity. In this case, that is x equals 0. So that is when x equals 0. Then, letter C, find the y-intercept by computing f at 0. So that means you are going to replace x by 0. So from the function here, you replace x by 0. So you have 0 to the 4th minus 0 squared. And that gives you 0. So f of 0 is just 0. And then next, letter D, we are to determine the symmetry of the graph. So we are to choose if it's even or odd. So that means you're just going to determine whether this function here is an odd or an even function. Now, to do that, let's recall a function is odd if f of negative x is equal to negative f of x. In other words, if you have a function and you replace all x by the negative of x, and you get the negative of f of x as your final result, then that function is an odd function. But if you have an even function, so if you replace x by negative x, and you get the original function back, then that function is even. So let's take a look at the function here. So you have f of x, which is equal to x to the 4th minus x squared. So now if we evaluate the function at negative x, so that means we replace the x by negative x. So you have negative x to the fourth minus negative x squared. This negative x to the fourth is the same as x to the fourth. And then negative x quantity squared is also just x squared. So you have minus x squared here. And guess what? We got the original function back. This is just equal to f of x. So we have seen an example where f of negative x is just equal to f of x. So that means this is an even function. So in other words, if the function is even, it is symmetric with respect to the y-axis. And then you can put together all the information that you have to actually determine the graph of the function. Well, now based on our result, the first one, if you remember, if you recall, the end behavior is letter C. The graph rises left and rises right. And then we also have the x-intercepts, which is 0, -1, and 1. So looks like all of these, looking at the end behavior, could be a possible graph. Then now let's look at the zeros. You can enlarge the graph here. You can expand that out and see if that's correct. So let's look at this one here. We have a 0 as the x-intercept, so it touches 0 and also -1 and 1. Those are the zeros, right? And that actually coincides to what we had. And also, based on our result, at x equals 0, the graph touches the x-axis because the multiplicity here was 2, and that was even. And then for -1 and 1, it crosses the x-axis. So this is actually the graph of the function. Now, next question. Use synthetic division and remainder theorem to find the indicated value. Now, on your test, you can either just use one of them, whichever is more convenient to you. The thing here is we want to find the value of the function at x equals 2. So what does that mean? That means you just replace all the x's here by x equals 2, by this value, to find the remainder. That was the remainder theorem. The remainder theorem states that if this function is divided by x minus the value here 2, the remainder is just the value of the function evaluated at this point. And so to do this, we are just going to replace x by 2. So you have 2 to the fourth plus 5 2 cubed plus 3 times 2 squared minus 3 times 2 minus 4. And then you simplify this using your calculator, where you have 16 plus 5 times 8 plus 3 times 4 minus, that is 6 minus 4. And you have 16 plus 40, this is 56, plus 12, and that is 68, minus 10. So that is equal to 58. So this means that 58 is the remainder when this function here is divided by x minus 2. And you can verify that also using synthetic division. Now, again, in the test, you don't need to do both. You just need to do that because you're just looking for the remainder. But for the purpose of review, I would show you how you would do synthetic division. So for synthetic division, you're going to make sure that this is arranged in decreasing order, and then you just copy the coefficient. So let's write down the coefficient. So you have 1, 5, 3, -3, and then negative 4. So this is the coefficient. 1 is the coefficient for the leading term. So 1 is the coefficient for x to the 4th, and then 5 for x cubed, 3 for x squared, negative 3 for x, and then negative 4 is the constant. Then you place here the value. So this one is, we're like dividing this by x minus 2. So you're going to get that value, that 2, then write that here. So now you bring down 1, you multiply 1 to 2 here, you put the product, so 1 times 2 is 2, then now you add. So you have 7. 7 times 2 is 14, and then you add. So that is equal to 17. And then 17 times 2 is 34. And then you add. That is equal to positive 31. 31 times 2 is equal to 62. 62, and then you add. That is equal to 58. So you see, you get the same value. This number here is the remainder when the function, the polynomial function, this function here is divided by x minus 2. And that is the same value you got using just the remainder theorem, which is just to evaluate the function at that value of x. Next question, you are to solve the equation here given that 2 is a 0 of this function. Find the solution set. When you are asked to solve, that means you are going to get all the zeros. So note that one of the 0 is already given. So we can use that given to actually find the rest of the zeros of the polynomial function here. Now, since this is already a 0, then we can use synthetic division to actually reduce or get the other factor of this polynomial. So let's use synthetic division. Let's write down the coefficient. So you have 1, 2, negative 5, and negative 6. So this is for 3, 2, 1, and that's a constant. Then you put 2 here. We expect that the remainder here is 0 because 2 is already given to be a 0. So you bring down 1, you multiply that by 2, so you have 2, and then you add, so you get 4, and then the answer here will be multiplied by 2, you get 8, and then you add. So negative 5 plus 8 is 3, times 2 is 6, so as expected, you get the 0. Now, the numbers here are actually the coefficients of the factor. So the factor will be a polynomial expression which is 1 degree less than the original expression. So this expression is of degree 3. Then this one here are the coefficients of the factor of degree 2, a polynomial of degree 2. So you have x squared, the coefficient is 1. For x squared, the coefficient of 1 is 1. And the next one, this 4 here is the coefficient of x. And this is your constant, so plus 3. That's the other factor. Note that that is quadratic. So now that we have a quadratic expression, we can now get the 0 by factoring this or using the quadratic formula if you can't factor it. But in this case, this can actually be factored. The factors here are x plus 3 and x plus 1. Those are the factors. Equate to 0. Then you have x equals negative 3 and x equals negative 1. So what's the solution set? You just write down the zeros. Now, most students would miss this. They would miss to write this as an additional 0. So don't forget that. So those are the zeros. The zeros are negative 1 or negative 3, negative 1, and 2. Those are the zeros. Now, when you plug in, pay attention that there's already a parenthesis here. So you don't need to put the parenthesis. You just put negative 3, negative 1, and 2. Now, for this equation, just apply that same principle. We'll skip that and move on to the next the next question here. Now for the next question, you are given a table. So for instance, you are given a table and the same thing, you are to find the solution set. So you are going to find the rest of the zeros. Now, if you are given a table, all you need to do is to look at the case where y is equal to 0. If y is equal to 0, that means that the x value there is an x-intercept. So that is a 0 of your function. Now, we will use that fact. We will use that as a starting point. So as again, same as what we did a while ago, we are going to use synthetic division so we can find the quadratic factor. Because you have a cubic factor here, so if we're going to perform synthetic division when x is equal to 2, then you get the coefficients of the other factor, which is a quadratic factor. So you have, let's do synthetic division. Let's write down the coefficient of x cubed, which is 16, negative 42 as coefficient of x squared, 21 as coefficient of x, and negative 2 for your constant. Then you use x equals 2. We know that when x is equal to 2, it should be a 0. So we should expect a remainder of 0 when we perform our synthetic division. So you bring down 16 times 2 is equal to 32. Then you add, that's negative 10, times 2 is negative 20. Then you add, that's 1, times 2 is positive 2. Then you have a 0 as expected. So therefore, you have 16x squared minus 10x plus 1 is equal to 0. Now you think of factors of this one. So if you could think of factors of this, then you can factor it out. So for instance, how do you factor that? How do you know if it's factorable or not? You multiply, or you can use the technique that you've learned. There are so many techniques in factoring quadratic, but my technique is to multiply the coefficients of x squared and the constant, so that is 16, and then I'll think of factors of 16 so that it gives me a sum of negative 10. So what's 16? 16 could be 4 times 4. If I add 16, that is just 8. But 16 could also be 2 times 8. And if you multiply 2, if you add 2 and 8, that's equal to 10. So those are the factors. So you will have 8x squared. Oh, no, not x squared. 8x. So you write this as factors. So you do 8x and then the other one is 2x. Those are the factors of 16, right? And then the factors of 1 will be written here. So you have 1, 1. Those are the factors of 1. Then the middle term is negative, so both of them will be negative. Then you double check. Multiply this 2, you get negative 2x. Multiply those 2, you get negative 8x. If you add, you should get the middle term here. The middle term is negative 10x. Okay, so that's how you know that you have factored it correctly. Let's erase that. Now, you equate this to 0. Then you compute for the remaining factors. So x is equal to, you equate this to 0. So for x, that is 1/8. The other one is x equals 1/2. So these are the zeros. Okay, so now let's go and take a look at how we would answer the question here. So which solution of the equation can be determined from the table? Which one? That is actually which solution? The solution is 2. So it's looking for the x coordinate. Now, what are the other solutions to the equation? The other solutions are these values here. So you have the 1/8 and the 1/2. Okay. Next, what about if you cannot factor it? If you cannot factor it, just use the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. Then you plug in the coefficients of your quadratic expression here. So this is your A, that's your B, and that's your C. You plug them in here, and then you solve for x. You should get that same values. All right, so let's move on to the next question. For the next question, it says here, use the following function to answer parts A through C. First, you are to list all possible rational zeros. Okay, so to list all possible rational zeros, we have the P over Q form, if you remember that on your notes. So the P are the factors of the constants here, 11, and the Q are all the possible factors of the constant here. So how do you do that? You write first all your P's. Your P's will be the possible factors of 11, which is only 1 and 11. And you always put plus or minus, or you can put that in, towards the end. And also your Q are all factors of 11 as well, because you have the coefficient of x squared is also 11. So you have 1 and 11 as well. Those are all the factors, because 11 is not factorable. Then you form a ratio between these two. So your P, so if the numerator is 1, and then you would always put plus or minus. Okay, so do plus or minus, let's write plus or minus first. 1 over 1, so that will just be 1. And then the other one is plus or minus 1 over 11. Then next, if the numerator is 11, so you have plus or minus 11 over 1, so that will just be 11. And the other one is plus or minus, if it's 11 over 11, that will just be 1. So that is the same as 1. So to write the answer here, sometimes you are to be careful, because if it's, MyMathLab is picky, so make sure you arrange it in order or not. Okay, so you are going to write this as plus or minus 1 over 11 from least to greatest, plus or minus 1, and plus or minus 11. Those are all the possible rational zeros. Now for letter B, it says here, use synthetic division to test the possible rational zeros and find the natural zeros. If that is challenging for you, I suggest that you just use the remainder theorem. So instead of the synthetic division, to find an actual zero for letter B, the first actual zero, just 1, among all these possible rational zeros here, because those are just possible rational zeros, not really are zeros. Okay, so one of them, or maybe few of them, are zeros. But to do that, to find your first zero, I would suggest to just use the remainder theorem. That means you're just going to plug this into that function, use the calculator, plug in these values here to your function, and see which one gives you a 0. Okay, so you have access to Desmos Scientific Calculator. You just plug in those values, replace the x here by the values of x's here. So you can do plus or minus, so you can try plus 11 and see what you get, or replace x by negative 11 and see what you get. So for the purpose of illustration, I'll show you one. So this is your Desmos Scientific Calculator. So you will have 11 and then your x. So x is, say for instance, we pick 1. You just pick, the hard one. Let's just do 11. So you have 11 and then cube. So for cube, you press that and then 3 and close it. Oops. Make sure it's in the middle. Okay, and then you enclose it, and plus 126. So you have 126x squared. So times 11, because x is 11 squared. Then plus 56. 56 times 11. Because the x there, you have x there. Replace x by 11. And then plus 11. What you get? Oh, you got 3,514, which is not a 0. So that means 11 is not a root. Let's see, let's copy that. Okay, so now for the next one, instead of 11, we will do negative 11. All right, maybe I'll put the negative 3 outside. Okay, so we have that one, and then there we go. Let's delete that. There we go. And then you have the 3 here. That would be easier. Okay, then delete that, and then you have a square. All right, so now instead of 11, we do negative 11, right? So we just replace that by negative 11. So it's a lot easier if you use this Desmos Scientific Calculator. And you have access to this one. Just open Desmos Calculator on your test. The link is provided. Or open it before you access your test. And you're actually allowed to access this during your test. Now, you see that it equates to 0. So therefore, this x equals negative 11 is a 0. Then you can use that as your first root. Then you use synthetic division. Okay, so now here, let's use synthetic division. So let's write down the coefficient. So we have 11. That's for x cubed, 126, 56, 11. We know that negative 11, based on our computations a while ago, negative 11 is a root. And so therefore, you have 11 times 11, negative 11 is negative 121. And then you add, this is 5, times negative 11 is negative 55. And then you add this, it's 1 times negative 11 is negative 11. That is equal to 0. Now, you have this factor here, 11x squared plus 5x plus 1 equal to 0. We want to solve for the roots of this quadratic function here. Note that this is not factorable because we cannot think of factors of 11. Factors of 11 is just 11 and 1. So we need the factors of 11 that would give you a sum of 5. So we know from here that this is not factorable. Or even if you're not so sure if it's factorable or not, and you can't really think of the factors, then go ahead and use the quadratic formula. So let's use the quadratic formula, which is negative, let me write down the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in the coefficient. So you have negative 5, b is 5, plus or minus the square root of b squared, so that's 5 squared, that's 25, minus 4 times a is 11 and c is 1. All over 2 times a, which is 11. And then you simplify this. To simplify it, you could plug this into your to the Desmos calculator. So you have a fraction, and then negative 5 plus or minus. So in this case, you just do plus first. There's no plus or minus. So you do plus first, and then you take the square root of 5 squared minus 4 times 11. 11 times 1 is 11. Or you can just write 44 there. And then 2 times 11, you can just say 22. Oh, probably the answer here, it says here undefined. So could be that the answer may be could be that the answer here is imaginary. Now, just take a look at this. What is, so you can go back and see, all right, what would cause this to be an imaginary if this is actually negative? So you can do step by step. So you go back and see, okay, 5 squared is 25 minus 4 times 11, that's 44, and that's equal to negative 19. So therefore, this is how you would write this. So the answer here will be negative 5. Then you have plus or minus the square root of 19i, because you have a negative 19, right? Divided by 22. So the denominator there is 22. So over 22. So this is actually the rest of your roots, the imaginary roots. All right, let's have another example. So here, answer the following questions about the equation below. You're given a polynomial equation. You are first to list all rational roots that are possible according to the rational zero theorem. And then you use synthetic division to test several possible rational roots in order to identify one actual root. Okay, so now, and then we answer the rest of the question. Okay, so first, let's determine the possible rational roots for the polynomial equation here. And so to do that, you are going to use P over Q, where P are all the possible factors of the constant here, and the Q are the possible factors of the coefficient of the leading term. So what I would do is I would list down my P's here. I will just write the positive, negative later. So for the P will just be 1 and 7. Those are the factors of 7. And then the Q's will be the factors of 12, which are 1 and 12. What else? You have 3 and 4. What else? 2 and 6. See, so 1 times 12 is 12. 3 times 4 is 12. Also 2 times 6 is 12. So those are all the possible roots. So now your numerator will just be 1 and 7. Okay, 1 and 7. So you divide. So you divide 1 by 1. So you have plus or minus 1. And then 1 by 12, you actually have that, right? So I think we focus first on, because this is a multiple choice question, you focus first on dividing all of this by this number here. So you have 1 and 7. That's plus or minus. So you have plus or minus 1 and plus or minus 7. So that is dividing 1 and 7 by 1. Next, you can do dividing 1 and 7 by the next smaller number. So that would be 1, and then you go to 2. So arrange this in order. So let's arrange that in order. That's 1, 2, 3, 4, 6, 12. So we will divide this by 2. So 1 and 7 divided by 2. Correct. So it looks like letter D is our answer. And then next, you divide 1 and 7 by 3. 1 and 7 by 3. So that would be this. And 1 and 7 by 4. And then by 6 and then by 12. So it looks like letter D is the answer. Now, to answer letter B, as I've said, instead of using synthetic division to test this, I would say you just use your calculator. You just use the remainder theorem. Okay, so let's illustrate this using the calculator. So we're just using the remainder theorem. So now you will have 12 and then quantity. So let's have the first 0. What would be our first 0? We can do 1. Okay, then you can just change that later. So you have 1 And then make sure you put the powers outside, so it would be easy later on to change the numbers. So negative 1 to the third minus, and then you have 91 quantity. Yes, we're using 1 here. Then you have power, and then squared plus 50. Now quantity, you just put quantity because we're going to replace that number. The number inside the quantity will be replaced later. Minus 7. Okay, so first, that is not a 0. Okay, so then you just copy that. You hit Control C on your computer, enter this. Then you paste it, Control V. See? Then now, replace that by -1. This by -1. And that by -1. See, you got -160. Okay, so then you try a different number. So you do that until you find 1, 0. Okay, and then for instance here, we replace it by the next number, which is actually a 7. So you do that. Let's do 7. Place that by 7. That value by 7, which we got a 0. So now we got our first 0. So we know 7 is a root. So then you can perform synthetic division. So one rational root of the given equation is 7. Now use the root from this letter B here to solve the equation. So we want to solve this equation. Then we can use synthetic division in this case. So you have 12 minus 91. And then 50 minus 7. And we got the 7 as a 0. So you have 12 times 7. That is equal to 84. And then you add this. That's -7. 7 times 7, -7 times 7 is -49. Add this is 1 times 7. We got a 0. Then next, you can factor x, 12x squared minus 7x minus 1, plus 1, is equal to 0. So if you could factor this, you can factor it, or if you can't think of the factors, just use a quadratic formula. So I'll factor this as 3x plus 1. Oh, they're both minus because the middle term is minus. Oops. So I have a minus here. Wait. And my eraser is not working. There we go. We'll just cross that out. So you have 3x minus 1 times 4x minus 1 is equal to 0. So those are the factors. You can check and then equate this to each factor to 0. So you have x equals 1/3 and x is equal to 1/4. Those are the remaining zeros. So now you're asked to find the solution set. So that means you include all the zeros. Include all the zeros, which are 7. That's the first one you got. And then 1/3, 1/4. Or you see is this required to be arranged in order? I don't think so. Okay, then, or you can arrange it in order just to be sure. Arrange this in order would be 1/4, 1/3, and 7. Those are the solution set. Now I guess I should stop here. again, instead of using synthetic division, since you're not allowed to use any graphing calculator, because this is a graphing test, I would say utilize the scientific calculator, this Desmos calculator, and also make sure that you use the remainder theorem instead. Okay, so you utilize your you utilize this Desmos scientific calculator and the remainder theorem to actually solve, instead of using the synthetic division, because that takes a longer time. It takes a long time to actually solve if you use that. All right, so I hope you find this useful.